In the last part of the tutorial, I will show my final processing procedure for the derotated image of Jupiter's disk using the excellent free Photopea software, very similar to Adobe Photoshop. The goal of this processing is to highlight as much detail as possible in the derotated and integrated image, while maintaining the disk's natural appearance in terms of colors and contrast, and without creating artifacts due to excessive image sharpening. I open the derotated Jupiter image from the Photopea program. I zoom in on Jupiter's disk to better see the details during processing. The first step is to initially sharpen the image. In order not to lose details in the brightest parts of the image, I will exclude them from this sharpening. Therefore, in I select Color Range menu I select Highlights, I set a fuzziness to about 15, and a minimum brightness to about 175. Then I click OK. To exclude this area, I use Select and Inverse commands. Before sharpening, I soften the edges of the selected area using the commands Select, Modify, Feather, set the value to 1 and click OK. I turn off the borders of the selected area using a combination of the Ctrl and H keys. In the initial sharpening, I first sharpen the smallest details of the image. I use the Smart Sharpen tool, which I launch with the commands Filter, Sharpen, Smart Sharpen. Now I turn on the Preview option. I set the initial amount to 100% and the radius to 1.5. After that I try various radius values from 1 to 2 and various amount values from 50% to 200% in order to find the combination that gives the most details without increasing the noise. In this processing step, the most important thing is to find the optimal value of the radius and amount parameters. If I choose a small radius value and a big amount, I will sharpen the noise in the image more than its real details. The amount value is related to the radius. If I choose a larger radius, I will have to choose a smaller amount, because otherwise I would overdo the contrasts of the sharpened details and the image will not look natural. These values seem optimal to me, so I will use them. At the end of the procedure, I just click OK. Now, using the same procedure, I perform Smart Sharpen one more time, but with larger radius and much smaller amount value. Here I will use 8 for radius and 5 for amount. This way I will sharpen the middle-sized details. Before final sharpening, I turn off the inverted selection of highlight parts of the image using the Select, Deselect commands. At the end, I perform sharpening on a large pixel scale in order to emphasize the largest details on the entire surface of the disk. This time I use the unsharp masking procedure. I use the sequence of commands Filter, Sharpen, Unsharp Mask. I select Amount 5, Radius 50, Threshold 0 and click OK. Now I adjust the left and the right side of the histogram on the background image using the commands Image, Adjustments, Levels. First, I move the right slider on the histogram to the left all the way to the right end of the highlighted part of the histogram. Then I click on the black square to the right of Sample from Image and check a sample size, frame upper left. If I do not see the sample size frame, I click again on the black square to the right of Sample from Image. The sample size should be 5 by 5 pixels. Now I place mouse pointer to any spot on the black background far from Jupiter's disk and click the mouse. This way I adjust the correct color balance of the image background. I finish by clicking OK. Now I will highlight the color levels a little better. First, I create a new layer by duplicating the background layer and name it as Color. The commands are Layer, Duplicate Layer. I double-click in New Layer, enter the label Color and click OK. I need to change the blending mode of the new layer to Color mode. Now I adjust the colors of the Color layer using the Levels function, in order to obtain more refined colors. The sequence of commands is Image, Adjustments, Levels. I click on the down arrow, check the Find Dark and Light Colors box and OK. I check the appearance of the enhanced color by toggling it on and off the Color layer. As we can see, the colors are now better highlighted and differentiated. Now I merge the Color layer with the background image. I turn on the Color layer, then right-click on it and select Merge Down. At this stage I notice that the edge of Jupiter is unnaturally sharp and too bright. I'll fix that with a light blur. First, I select the dark background. Among the tools in the bar on the left, select Magic Wand tool, set Feather to 1, set Tolerance to 5, turn on Anti-Alias and Contiguous options, turn off Sample All Layers. I put the mouse somewhere on the black background away from the Jupiter disk and click with the mouse to select. I alternately click a couple of times on various parts of the background. If I can't get a selection that fits well around the edge of the disk, I increase the tolerance and try again. I will see the selected edge better if I alternately turn it on and off with the Ctrl+H keys. I finish when the edge of the selected background precisely follows the edge of Jupiter's disk, and here it is at a tolerance of 15. Now I soften the edge of the selected part, select Modify Feather, set the value to 2 and click OK. In some cases, if my Jupiter disk is larger, I choose 3 for feather, and if it is smaller, then 1. Now I copy the selected part of the background to a new layer with the commands Layer, New Layer via Copy, and in the Layers window I change its blending mode to Darken. I soften the edge of Jupiter by blurring that new layer in Darken mode. In the Filter menu, I select Filter, Blur, Gaussian Blur. In the Gaussian Blur window, I enter a value of 1/4 radius and increase it as needed. I check the effect by turning the Preview option on and off. After a few tries, I will set the value to 1.4 because it looks best to me. I finish by clicking OK. Now I just merge all the layers into one. I right-click on any layer and select Flatten Image at the bottom of the menu. Now I move on to softening the contrast and lighting of the brightest parts of Jupiter's disk in order to preserve as much detail as possible. Image, Adjustments, Shadows/Highlights. For shadows, I set amount 0. For highlights, I set amount 5. Tone will be between 30 and 40. Radius will be 1. Color correction, I set to +10. I check the effect by turning the Preview option on and off. If the detail improvement in the brightest parts is not visible enough, I increase the amount value a little. With a tone of 40, I'll set the amount to 10. Finally, I click OK. Now I have to check and stretch the entire RGB histogram again. The procedure is standard. Image Adjustments, Levels. I move the left slider under the histogram slightly to the right until I cross these high black lines of the histogram, and I move the right slider to the left all the way to the right end of the highlighted part of the histogram. I finish by clicking OK. Now I repeat the softening of the contrast of the brightest parts of Jupiter's disk in order to improve the detail as much as possible. Image Adjustments, Shadows/Highlights. For shadows, I will leave the amount at 0. For highlights, I set amount to 3. Tone will be 40. Radius will be 1. Color correction, I set to 0. I check the effect by turning the Preview option on and off. Finally, I have to remove the remaining noise in the image. I use the built-in noise removal tool, Filter, Noise, Reduce Noise. I will turn on the Preview option. In this process, I have to find the optimal values for Strength, which represents the intensity of noise removal, then Protect Details, which determines the percentage of details I want to preserve from noise removal, and Reduce Color Noise, which determines the intensity of color noise reduction. First, I set them all to 0, and I start by increasing the Strength value just until I remove the noise, and then increase Protect Details until I get new details, but no noise. I try to choose the smallest strength and the largest Protect Details without noise. Finally, looking at the noise, I add Reduce Color Noise, but as little as possible. By trying various combinations of these parameters, I get the one that removes the noise best, while leaving the most details that are sufficiently, but not too sharp. I end with OK. At the end I will just sharpen the image a little. I'll use the Smart Sharpen tool with amount set to 15% and the radius to 1.5. Finally, I save the finished photo in 16-bit TIFF or PNG format. Since this is the end of the complete processing of the image of Jupiter's disk, I will compare the images by individual stages to see how much information I managed to obtain by processing the original recorded material. I will compare the best frame from the best video, the stacked image obtained from the same video, the sharpened image obtained with the Registax program, the derotated image obtained with the WinJUPOS program, and finally the final image obtained by processing the derotated image in the Photopea program. I think the difference in the amount of detail in the images after each individual processing step is clearly visible. Thank you for following this tutorial. I hope you find it useful in your planetary astrophotography. I wish you a lot of clear skies and good seeing.